missed something or you're reviewing over the weekend, Sunday night, you're like, let me get my review out. I always forgot how to do those steps in the calculator. You can check the video, of course, on Canvas, okay? And then, yeah. All right, so I promise you when I tell you the review is just like the test, I mean it. I keep telling you guys this. I want you to trust me. I kept it in the same order. And I just changed the numbers or signs in most cases, okay? So truly, if you know how to do number 9 on the review, you should have no problem doing number 9 on the test, okay? So let's start there. We'll go through. And there's lots of calculator stuff on here, so let's be ready to go. Okay, so guys, it says to find the zeros, x-intercepts, solutions, roots, all different words for the same thing. This is factoring, and there's 4 terms, so we can use the grouping method. You might notice that you can factor a 2 out of all 4 of those. So if it was just factoring, like if it said factor this, that's the first thing you would do. But since we're solving, you can kind of get away with not factoring out the 2, which I didn't, but either way would be fine. So you're going to do the grouping method. And I'm going to factor out, I'm going to go over here and write it, factor out the GCF of the first 2 terms. So 2 is the biggest number, x squared would be the amount of x's they have in common, and then what's left over goes in parentheses, right? Don't forget, when that first term in the parentheses is negative, you always have to factor out a negative. So I'll be looking at this work, so make sure you show it. And you can use your calculator, but you should find that 32 goes into both of those. Always try the smaller number of the 2, because a lot of times that's it. Gary, put your phone away for me. And then I'm dividing both of those by negative 32, and I have x minus 3. Remember, your parentheses should be the same. So what I have factored-wise is this, right? The parentheses and then the GCS. But we want the actual 0. So we set them equal to 0 and solve. So when I set x minus 3 equal to 0 and solve, of course I get 3, right? When I set 2x squared minus 32 equal to 0, I would add 32, right? You don't have to show that step, okay? So when I say to show work, I'm not unreasonable, okay? Then divide by 2, and then we do the square root. So what's important right here, I mean, I don't think anybody has a problem getting to here. It's remembering that when you take the square root of something, you get 2 solutions. That's going to make the difference between whether you choose A or B, or A and C, right? So A would be our answer. These 2, right? So factoring. For some reason, I printed the one that I didn't write on. So grab this. Okay, so number 10 is building a rational function. Rational function is a poly on top and a poly on the bottom. And what they give us is that they give us a whole and they give us an asymptote. We need to remember that wholes and asymptotes come from our denominator, okay? So as I start building this, I have x equals negative 1 is the 0, but remember, I want to write it as a factor, so bring that negative 1 back to the other side of the equal sign. So x equals negative 1 becomes x plus 1 as a factor, and this vertical asymptote at x equals 3 would have been x minus 3, right? And we know to put them in the denominator because that's where they originate from. And one more thing that we know is that wholes cancel. So if this is a whole, then we have to have that identical factor in the numerator. Okay, and that's everything we have. So we have to figure out which one of these matches this. So first thing I would do is FOIL the denominator. Because when I FOIL this, I'll know I can probably narrow my choices down. So when I say multiply them together, right, that's x times x is x squared, x times negative 3, 1 times x, 1 times negative 3, and then combine my middle terms. Right, so that's my denominator. Everybody understand how I got that? So that narrows it down to definitely it's got to be A or D. Okay, so right there I'm at a 50-50 chance. Now I still have this x plus 1 on top, but I don't know what the other factor is to figure out the whole thing. So what I could do is factor these two numerators and see which one has a factor of x plus 1. So by narrowing it down to 2, it's a lot less work, right? So if I just factor this, sorry, I'm kind of squeezing it in here. If I factor this, which numbers multiply to get 2, add to get 3, that would be 1 and 2, right? 1 times 2, and then plus 2, whatever. And over here, now I see that that has x plus 1 in it, so I'm pretty sure that's the answer, right? But why not just double check to make sure you didn't make a mistake somewhere else? Let me just factor this numerator real quick. The two numbers that it's a chart problem, I'm just not making the chart. Two numbers that multiply to get -6, add to get -1 would be -3 and +2. So we know it can't be A, that leaves us only D. So this is, manipulating the multiple choices to help us, right? Using the choices to lead us to an answer. Do we get that? Yeah. Yeah, because if you're a whole, so they gave us that that was going to be a whole, by definition, a whole is a whole because it has a factor that matches it in the numerator that cancels it. So that's how I knew to put that there. Okay. Okay, number 11, if you happen to look ahead at the key you start working, you might have noticed I factored the numerator on this problem, but I didn't really need to. Okay, so saving you some work here, it says to determine the domain. The domain of something that's not a fraction, so let's take this rational function away and just make it a polynomial like the numerator. It's all real numbers, right? The fraction is what causes problems. So that means the denominator causes us problems. The numerator is not a problem. We don't need to factor it. The only time we would need to factor it is if we were trying to determine wholes and VAs, right? Do we cancel or not cancel and that kind of thing? Or what the x-intercepts, they come from the numerator. But the domain is all real numbers, right? Except what makes our denominator what? 0, right? Your denominator cannot equal 0. So again with the factoring, I'm going to just factor that denominator. This is again a chart problem. You can make the chart. You don't have to make the chart. You can do it in your head, whatever you need to do. I'm not going to ever tell you you're showing too much work, okay? But what I model for you is pretty much the amount of work you would be required to show. What two numbers multiply to get -21, add to get -4. Oops, that's a minus. That's what I meant to write there. I don't know why I just didn't make the plus one. Okay, so -7 and +3, right? That's what the denominator's factors are. But don't forget, you have to set them equal to 0 and solve in your head, right? X can't be 7, because that would make this 0, or -3, because that would make this 0. So those are our two problem numbers. But we can have everything else. So you're just choosing the interval notation that matches that. So you want from -infinity up to -3, then between -3 and 7, and then from 7 to infinity. It should all be parentheses, right? Because we're not including those. We go right up to -3, skip over it, and then keep going. All right, so no brackets on that. Good? All right, so now, yeah, it's just a factoring problem. And don't waste time factoring the numerator on that one. And like I said, number 11 is going to be the same type of problem. So number 11, you should be like, oh, that's right. She said don't factor the numerator. I don't even scramble the questions, okay? All right, 12, 13, and 14 are all calculator problems. So let's get those ready to go. Let's clear the RAM. Does everybody remember how to do that? Second plus 7, 1, 2. So clear your RAM. All right, so there's really two major things we're using on the calculator for this test. We're using the stat enter thing, and we're using the y equals, okay? So sometimes I get the question of how do I know which one? Okay, so we're going to be talking about that as we go. So we have our RAM cleared, and let me read this question to you. When a hobby rocket is fired from ground level, the distance above the ground can be found by S of t equals blah, 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 where t is measured in seconds. During what time intervals is the rocket at least 42 feet above the ground? So when I read all that, I usually read a word problem fast, like I just did, and then I kind of go focus on what I need to focus on. And so one of the things I like to do is kind of think about what the variables mean. So it told us that t is the time in seconds, right? And s of t is your feet above ground, okay? And so what it's asking for is what time, so what is the x value when we're at least 42, which is the y value. So you don't have to write that, but that's what's kind of going on in my head. I'm like, okay, so what they're saying is I need to find the x value or values when y is 42, okay? So let's start by putting this in our calculator. We're not going to use the stat button. This is an equation, all right? So you literally go up to y equals, and you type it in. And instead of t, of course, you can use x, right? That's what x is, minus 16x squared. And we can graph it, hit graph, and look at it. And you're not going to see much. Okay? Doesn't mean you did anything wrong. It's just our window, and we'll talk about that. But the question, what everyone wants to do when there's an ordered pair is go to the table. And the table is wonderful. We're going to be using it on another problem. But the table doesn't work for us when we're looking for x given y. It works awesome when we're given x and need y, but in the other direction, it doesn't work. So number 12 on your test might be a plus sign in between. It might be a 69 and a 15 or something, but it's going to look just like this. So what we do is we want to find the intersection, okay? And I'll explain why. So do this for me. Go back to y equals and put a second equation in of 42. What this is going to do when we fix our window is it's going to show where 42 is on your graph. So let's see what that looks like. So obviously, that doesn't look like what it should look like. It should look like a parabola. This is x to the second power. It should go up and then down, right? Or no, it should go up and then down. So I'm going to change my window. So I'm going to go to window, and every time you clear the RAM, guys, it goes back to 10s, 10 in every direction, okay? And that's not realistic for a lot of word problems, right? We need to change this. How do I know what to change it to? Well, I need to go at least as high as 42, right? Right now, it only goes up to 10. So y max has to get changed. Don't change it to 42. That's only going to get us to one part of the parabola. What do you change it to? I'm going to say, I don't know. I don't know. I'm going to guess just like you are. But it's okay. If I put 50 and I hit graph and I don't like it, you guys are like afraid to go back and forth. You can go change things. I want to go higher. I want to see where it turns, even though this really is good enough. But don't be shy about going back and saying, okay, I'm going to go a little bit higher. Maybe go to 90. I don't know. So there's not like a wrong number. You just want to be able to see your intersections. Okay? So understand how this worked. That is 42, right? That's a horizontal line at 42. So if I find where the two graphs are intersecting each other, there and there, that will give me the ordered pair, which of course I want the x value of. Okay? So to be able to find a zero, a max, a min, an intersection, you have to see whatever it is you're doing. So you might have to change the window like we did. And then to find, and remember, you can't really mess this up. If you're like, I don't remember where the intersection button is, you can look for it. Don't be shy about saying, oh, is it here? Oh, no, that's not it. Is it here? Oh, I don't even know what that is. Oh, there it is. Okay, so it's okay to press some buttons. Everything's still stored. You're just looking around. So it's on Calc. So second Calc, and then we want number 5, which is intersection. Really simple, guys. Instead of like left bound, right bound, it'll say first curve, second curve. Just get on either side of the whatever you're looking for. In this case, it's the intersection. So, you know, I'm looking for my cursor. Okay, there it is. So I want to get, why is it there? Why is it going there? Okay, so you want to be on the curve. So if you notice, my cursor was on the line. We do want it to be on the curve. Okay, so, and sometimes I can't see my cursor very well, so I might sit here and play with it for a minute. So you're watching me kind of play with it. Okay, so I'm like below that intersection right now. Does it matter how far below? No, I'm below it. I hit enter. Okay, now I'm going to arrow above it, and it's actually going to take us along the horizontal line. That's normal. It's fine. Just get to the right of the intersection. Second curve. Yes, please. Notice it says y is 42, as it should. And then it says, do you want me to guess? Yes. And it's going to give us x is 0.75 when y is 42. Bingo. There's one of my intersections. And yay, bonus, it's on one of the answers, right? In fact, I probably feel pretty secure that that's my only answer. That's the final answer because that's the only choice that has 0.75 in it. But let's practice getting the other intersection, okay? So just hit it. You have to hit intersection again. So second, calc, intersect. And sometimes I forget to tell it I want an intersection. I start moving. It's okay. Get over to where you want to be, and you could have hit intersection at that point, okay? So I already told it that I want to do intersection, so I'm above it. Yeah.
Second, third, if I had to put something, did I miss something?
Are you on this intersection right now?
Yeah.
Okay, so watch me and then I'll come over. So enter, and then second curve, make sure you're moving your cursor enough so you can see it. So I'm to the right of it now, enter, yes, guess, and I get 3.5 as my other intersection. Okay? So
Did I have to?
hopefully, if not, maybe start. How did I get that? Y equals, and then I put a second equation in of 42. That's a horizontal line. Okay. So number 12 is going to be the same type of problem. You're going to find your intersection, the same exact steps. Okay. You have to find time to figure that out, Tyler. Okay. Don't let me forget. All right. Let's go on to 13. So clear your RAM again. Always clear your RAM. So the table below represents the population of a new community over a 5-year period. Find a regression model, that should sound familiar, that represents the population and then predict what the population would be after year 6. And if you looked ahead on the review, I had written these steps for you. I wrote them on the test as well. Okay, these steps are written just like this on your test. So let's go through it and make sure we understand what those steps mean. Because I'm giving that to you, you have to know what to do with it, okay? So we cleared our RAM, and it says to go to stat enter. We go to stat enter, not y equals, because we're putting in ordered pairs, okay? And so stat enter, and you should have your list 1, list 2. If something like that pops up on the test, of course I'll fix it for you, okay? But I can't tell you how to do this. All right, so stat enter, and then put your data in. 1, 2, 3, 4, 5, and so on. So everybody should be typing that in so you're not behind. You don't have time to write all that. It's written on your test, and if you look on, yep, I just said it's written right on your test. Okay, so we enter data. We're going to get to that. I just see a lot of people typing still, so I didn't want to get too far ahead. Okay, so stat enter, turn plot on. Remember, second, stat plot. It says off, so I hit enter to get into the menu. Hit enter again, and it highlights on. Now it's on. If you're not sure if you turn it on, you can go back to stat plot and see. Oh, yeah, now it says on. Okay. Then it says zoom 9, and you should see your graph at that point. Now, our next step is to go get the equations, stat, calc, and so on. Now, it didn't tell us in the directions if this is linear or quadratic. We know it's one or the other because of the choices, right? And instead of we did one day, we did an example, we had to type it in 3 different times and see which one fit best. But look at this. What do you think that is? Does that look more like a line or more like a parabola or quadratic? It looks more like a what? Quadratic, yeah. Stat, and the second stat. Right here. Did you get that? and then enter. Did you get there? Okay. So then zoom 9. Okay. So now we know it's going to be a quadratic. So we go to Stat, Calc, Stat, over to Calc, and we decided quadratic. So that's choose your regression line, is what that means, reg. So we're choosing quadratic. Next set of directions, store it. Go down to store. What do we press? Alpha trace. Alpha, yeah, same button. Enter. And then hit enter till you get your equation. Now, there's only one choice here that matches that, which is B. But let's just go that one step further and finish the problem, estimating the population in the following year, which is P of 6. So that's your table. What is Y when X is 6? We get to use our table with that. So second table, and we want to just go to 6. It's right there at the bottom, 11385. It matches perfectly. Things look good. Okay, did you get there, Annie? Okay, so where did you get lost? So you turned your stat plot on, right? So does it say on right now? Okay, then zoom 9. You should see your graph. Then Stat Calc. You want number 5. Stat. So Stat, and then over to Calc. Okay, you were doing second Calc? Okay, and then number 5 is quadratic. Okay, do you remember the rest of it now? Okay, I'm going to have to come during lunch or after school. I gotta keep going, or go back to the notes or watch the video again, but I will try and help you guys at the end. I got to get through all the problems, though. Okay, so number 14 is another word problem, obviously a calculator problem. Let's go ahead and clear our RAM again. If you don't clear your RAM, your settings are all changed, and that could really mess you up, okay? So each time you're going to do one of these, clear your RAM. And it's telling you that this is an equation that models the rate of people entering the departing flights area of an airport, okay? And what they want to know is, when does the rate of people entering the departure area change from increasing to decreasing? So it's like a flood of people, but when does it start to slow down? Think about on a graph. That's a turning point, also known as a maximum, okay? So we're increasing and then we're decreasing. When does that happen? What X value does that happen at? So I even wrote the directions on the test. So what you see here is what I wrote on the test. Try to give you a few hints on some of these. You're going to go, it's an equation, so we're not using stat, right? We're not doing ordered pairs. We're going up to y equals. So everybody doing this. So we're not behind. 0.03. So type this in exactly like you see it. Don't miss a decimal point. That's what held a bunch of us back last period because they didn't have the decimal points and it messed up their whole graph. So take your time typing it in, okay? We're actually doing really good on time, so there should be time for us to fix calculator problems, Tyler and Ann. Okay, we have it typed in. Okay. So, as he's finishing that, think about what we're trying to find. The turning point, the maximum, increasing to decreasing. So, I need to see that on my screen. So let's hit graph, and you're not going to see much, again. It's going way up there, okay? So it's normal. A lot of times, it's not that you did anything wrong, but these real-world problems don't normally go out to 10, 10, 10, 10. Remember, that's what your window is set to by default. So I know by looking at that graph that it's going up, and it's going to turn around somewhere up there. So that's telling me change my Y max. Tyler, are you still typing that in?
Yes.
Okay. So, guys, play with your y max. I don't have an answer for you. There's not even a hint here, really, that tells me what it should be. Pick something. What you need to see is where it turns in your window. That's how you know you picked a good number, okay? We don't all have to have the same one. Sometimes I go way too high. I don't like it. Like, I picked 100. That's fine. You could change it. I mean, maybe, oops, that's not what I meant to do. Negative 10. So maybe change it to 70 if you want it to be a little bigger. Like, you can play with it. Okay? Now, we need to find the maximum, okay? That's a pretty weird looking graph, right? But this is what's great about these calculators. You know that even though this looks like it goes straight across, kind of, it doesn't. There's no, like, line segment in a polynomial. It's a t to the third, so it's going to go up and then down, and something, all kinds of stuff could be happening over there. But all we care about is where is it turning into going down up here? And trust me, it does, even though we don't really see it. So here's what's really cool. To find the maximum, remember we're going to go to Calc. That's where we did the intersection earlier. Okay, we're going to do max, so hit 4. And I don't know exactly where it is. Like, sometimes it's really clear, like on a really, like, sharp turn, you know exactly where the left and the right is. I don't know exactly where it is, but here's what's neat. You don't have to get right up against it. You just have to be to the left of it. So if you look at my cursor, I might get up to, like, I don't know, here. That's far enough away, okay? Could have done it a little further back as well. And I'm going to hit enter. And then I'm going to go way to the right. Because where my cursor is now, it's somewhere in here. My maximum is somewhere in here. I don't know where. But I'm going to just get my cursor way over. I'm to the right of my maximum. I hit enter. And then I'm going to hit enter again. And it's, what is my x value? It's 6.471. Because remember, time is my t. That's what it says. At what time does it, and this is what, in hours? Hours, yeah. So after 6.471 hours. Okay? So the whole point of it is you need to be to the left and the right of an intersection, of a maximum, of a zero, of a minimum. It doesn't have to be right next to it. So I made a really big area for it to choose the maximum. And I just proved to you that that's fine. Okay, it doesn't have to be exactly right there, because I didn't know where it was. Okay? Good on that one? Okay, so I did write that on your test. Okay? Number 15 is a freebie. Every single one of you better get 15 right. Let's put our phones down. I see like half of you on your phone. This is why I don't let you guys have phones during class, because you guys cannot resist. Okay? Number 15 is a freebie. After I explain it to you, because looking at it right now, you're probably like, whoa, that's a lot. Like, let me just start reading to you. The polynomial function k is given to us by this. It doesn't even give us an a value or a b value, right? But it does tell us that it's a quartic. It's a degree 4. What do we know about a degree? It tells us the number of solutions. We know there's 4 solutions, okay? That's all I can really get out of that. Non-zero, blah, blah, blah. Each of the zeros has a multiplicity of 1. Okay, what does that mean? They're all 4 different zeros. Okay. The graph of the function in the xy plane has an x-intercept of that. Okay. Ooh, that's probably important because I underlined it. A 0 is blah, blah, blah minus something I. It's an I, imaginary number. Which of the following statements must be true? So let me go back to the concept of this. If I ask you guys to find the zeros of this answer, solve it, find the x-intercept, whatever. You'd say, oh, okay, no problem. I'm going to do the square root of both sides. I always get 2 solutions, and my answer would be 2i, right? 2 solutions. And I would say to you before, when we learned about this, i's always travel in pairs. If you have a positive I as an answer, you have to have a negative I because of where it originates from. Always. So we don't know how they got this answer. We don't really care. But they're telling us that is one of the 4 solutions. So we 100% know that there's another solution that's just like it, but with a plus in front of the I. They're called conjugates. Okay? That's a 100% fact. that they travel in pairs. Okay, so that's the answer, but let's go through the other choices to say why the other ones aren't. So the first one says that there's 4 real solutions. There are 4 solutions, right? There are 4, but they're not all real because they already told us one of them has an I in it, which makes it imaginary. So it can't be 4 real solutions, okay? It has 3 x-intercepts. Well, no, 2 of our solutions are imaginary. There are only 2 x-intercepts. Imaginary numbers, we don't see them on our normal xy plane, okay? So 2 of them are imaginary, 2 of them are real. We only have 2 x-intercepts. And I don't even know what this last one is, okay? So it's not even something we talk about. But so number 15 on your test is exactly like this. So if you get 15 wrong, that means you were not paying attention during this review because it's a freebie. There's no work to show. It's just remembering. Yep. Okay, so that's it for the multiple choice. Now we're going to go to the FRQ. And at first you're going to think this looks hard. I promise you it is not. And remember I was showing you the answer sheet that you're going to use on Monday? So remember I covered this up? Look at your review in front of you and then glance up here and see what I'm getting at. Look at your review and look at the answer sheet for the test. Okay? So when I say I'm making it exactly the same, I mean I'm making it exactly the same. What's under my thumb is just a different equation than this. It looks almost like it, I will tell you, okay? So I'm going to go over this. You should feel very comfortable on Monday that when you get to the same problem on the test, it's the same exact steps, okay? No tricks, okay? Here we go. So here's an equation that represents a rare species of fish that were found in the Everglades. Scientists have relocated the fish into a protected area. The population, P, of the fish, T, in months, I bolded that, must be a reason for that, after being moved is given by this. So scientists come up with this fancy equation. We're not scientists, we're mathematicians. We're just going to interpret data we can get out of it. So they give us this equation that represents the population of this fish. Okay. Now, you can probably guess you're going to have to put it in your calculator. And if you've looked ahead at my key, I gave some pretty explicit directions about how to put this in your calculator. And then I walked away from it and I thought, wait, there's a much easier way to do this. Let's simplify this one step and then put it in the calculator. Then we don't have to use 500 sets of parentheses. So what I'm talking about is if I told you we were going to work with a problem like this, you might want to distribute the x and kind of see it in its standard form because it's easier to kind of see, oh, it's a quadratic and things like that, okay? So it's the same idea, just with a rational expression, and that is I'm going to distribute the 375 to the parentheses. So I don't have parentheses anymore, okay? So don't forget this, though. This is a mistake I always see. We're distributing the 375 to the numerator only. Because remember, with multiplying fractions, okay, let's make the 375 a fraction, you just multiply straight across, right? You multiply numerators together, denominators together. So the denominator is really multiplied by 1, which would just be that. And then distribute the numerator. 375 times 1 is 375. 375 times 0.5 right in my calculator gives me where? Oh, the answer? Okay, I thought you were correcting something I wrote wrong. I just showed you the test. I was just showing you the test. Yeah. I was showing you the test, not the review question. That's what I was saying. Nobody's paying attention. Okay. Let me get the rest of my review. I wonder if I did that in the other classes. I might have. I don't know. Nobody said anything. I think I did. Wait, I'm so confused. Oh, yeah. I did it right. I was right. That wasn't the test. Yours says 0.1? It's just a 1. It must be. Yeah. Okay. Moral of the story is it's just 1, but on the okay, so I didn't make a mistake. Thank goodness. Thank you, Sadie. I didn't make a mistake, but the test is printed big and it won't have that on it. Okay, so no big deal. Distribute the 375. You should have this. Okay? This is what we're going to put in the calculator. Okay. Back to normal. Sorry. When you put this in your calculator, I would put the numerator and the denominator in parentheses. Why? You might not need to. Sometimes I don't take the time to even wonder about it because it's really never wrong to use parentheses, but typically when there's a plus or a minus or a multiply or divide in a fraction, you need to put it in parentheses. So that is my advice, and I'm not going to take the time to see if it matters or not. I just am going to go right into assuming it does. So instead of t, I'm putting x, right? Did I put the parentheses? Yeah. So whole numerator, close your parentheses. Gary, I don't know why you're on your phone still and not doing this. Come on. 3 plus 0.02x. And when you're going to hit enter or graph or something, you can close the parentheses, but you don't have to. If you're done, it kind of knows to put the parentheses there, so it's fine. Okay, so we can graph it, but the graph's not going to do anything for us. We don't really need the graph for anything, okay? Because look ahead what we're going to find. How many fish were found initially? That's an x value, right? Time. So can't I just use my table? What is initially translated to in numbers? 0. So I'm going to find P of 0 using my chart, my XY chart, my table. So 125 fish. Right? There's no work. It's just knowing where to find it. Initially, in the beginning. 0. Before any time has gone by. Okay? Now, Levi, after 5 years. So the reason that's bolded is because you're not going to plug 5 in, right? That's years. 5 times 12, right? 12 months in every year is 60 months. So P of 60, using your chart. Now listen, look at the bottom. I already showed you before, you could go to second table set and change this, but it gives you a quick option right there. See how it says press plus for change in table? That's how you want to count it. So if I just hit plus, and it says, what do you want to change the table by? What if I put 60? If I just put 60 and then go back to my, or hit enter, I'm already in my table. Look, 0, 60. I don't have to scroll at all. I mean, you could have scrolled all the way to 60 and found this number, but that's a quick way of changing it. The other place you can find that is second table set, and you can go there. Okay, and that's where you can change the number that you start by, what you count by. Yeah. Right here, it said press plus for change table. Okay, so moral of the story here is that our answer, now I am not going to be picky about if you make it a decimal. I know it says around the nearest 100 fish. That's, I guess they mean like 2,800. So I would accept that. I'm not going to be picky. Okay, so as long as it's like, you can just give me the decimal answer. Let's just go with that. Okay, so putting it in the calculator, 0, and whatever the number of months are, right? Just using your table. This last two are kind of answered together. This is really the only thing that we touched on, but we didn't go deep into it. So it's asking for limit notation to state the end behavior of this population. So in a rational function, the end behavior actually ends up being your horizontal asymptote. As you go to the left and the right, you can't go up or down past a horizontal asymptote, okay? And when it's a word problem, we normally don't really even care about the left end behavior because it's 0. It always goes to 0. But what we do care about is the limit of this function. I called it P of t. as x approaches infinity, to the right. What we're going to get right here is whatever our horizontal asymptote is. So I'll explain that as we go. Really simple, actually. If you think back to how to find HAs, you look at the degree of your numerator and your denominator. So looking back up at the equation, even though it's not in standard form, the biggest exponent is on our t's, right? Not the numbers out in front. So we really have t to the first over t to the first, right? And whenever they equal each other, you then look at the coefficients. What is a? It's the number in front of that t. You know, we've had a ton of these. There was like 10 over 5, and you wrote 2. Well, we're in decimals, that's all. So the number in front of the numerator's t is 187.5. The number in front of our denominator's t is 0.02. What do you think we do with those two numbers? Divide them. Yeah. So anytime you're in somewhere you feel like you can't get out of it, you can always use your second quit right next to each other. That always brings you back to the home screen. Okay? So 187.5 divided by 0.02 gets us a horizontal asymptote of this. So if you graph this, and it's in there, but I don't want to go all the way up to 9,000. It's a waste of time. But that's as high as the graph can go. It won't go past that. Think about the horizontal asymptote. So as you go to the right, you can never get past that horizontal asymptote. That is the limit as you go to the right. Okay? And that's the only one you have to worry about. Or it's going to be the same type of problem, guys. Same exact steps, different numbers. Last question. What's the largest population that the new area can sustain? This number, right? Can't go any higher than that. So could we get into technicalities of like, okay, if that's the limit, you'll never reach it. So somebody might say, this many, I would accept it. You might say this many, I will accept it. Okay? I'll get more strict second semester with stuff like that, but right now, getting to know the class. But that's your limit of fish. That's what that means. It's your limit. Can't go any higher than that, according to this model. Okay? Okay. Annie, did you figure out the issue on that last one? You did? Are you sure? Okay. Tyler, did you figure out the issue on that one? Go back and look at that one. Okay? While he's doing that again, does anybody have questions on the beginning of the review that they didn't get answered yesterday? Here's the steps if you need to see it, Tyler. Huh? What are you saying? Review? I say review. Okay. Whatever. Whatever. I think you know what I'm saying. What I mean. Questions, questions, questions. You can check. I didn't hear anything, but that doesn't mean anything either. I'll be here after school for a half hour if anybody wants to come. I'm here early on Monday as well. Oh, what one was it? Oh, okay. Did you clear your RAM first? now you kept going. And that 27 times is the first. Okay. Now we want to find another one. Again. So, I'm going to make it bigger. I'm going to so second count. I need to get on it. Now I'm on the computer. I'm on the first. Okay. So as long as I am, below it or below it, that's my first. Get past it.
Should have been some time.
Oh, point back.
I hope there isn't like a software bug on mine. That one makes sense.
You don't like that. Spread out the time. So maybe together. Maybe let's change it. Okay, so where is our and now I'm on the curve right below it. I either move there first or my myself and then so it's like the first one was first, and then you know it jumped over to the right. And then the first part of that, so we have a right back at okay, intersection on the curve. I'm trying to take it off. It should be. Okay.